A very fine morning to all. Welcome to the live class. Today, in this live session, I am going to start lesson number 4. That is here simply about light. Here in this chapter, especially you are going to learn about chapter number 4. That is the property of light is refraction of light at curved surfaces. Already some information you learned in your ninth class, that is regarding refraction of light at plane surfaces. Refraction of light at plane surfaces. Already the information regarding light refraction, what is refraction, what is refractive index, and when the light refracts, what happens when there is change in the medium, what is denser medium, what is a rarer medium, like that information you learned in your ninth class. So here regarding plane surface only, that phenomenon discussed in your class 9. But now in this we are learning about the process of refraction, what is curved surfaces, what happens when the light changes its medium from rarer to the denser, that is specially curved surfaces. So here in your textbook, in the introduction part, so I'm showing you the textbook part, that introduction page of the lesson also. In this we have discussion about a previous class knowledge as what is light. So here simply in the first lesson we decided what is light. Light is said to be here a source of energy. Light is said to be a source of energy, and it is an electromagnetic wave. It enables us to see the surroundings, and it is propagating with a speed called 3 into 10 to the power 8 meter per second in the vacuum. So here the properties of light also discussed in the lesson number 1 in the reflection of light. So here what they are here: rectilinear propagation of light, reflection of light, refraction of light, dispersion of light, diffraction of light, scattering of light, then here interference and polarization. So these are the major properties that we are discussing in the optics. So here already the discussion is completed about rectilinear propagation and reflection. Then the next property of light that we are discussing in this chapter is refraction. So simply, what is refraction of light? So here what is refraction of light means, simply we can say change in the direction of light. That simply in our regular words we are using as bending, changing its direction at a point where it can change its medium, that we can use as interface, right? So here bending of light ray at the interface, bending of a light ray at the interface is defined as a refraction of a light. Simple. Here suppose there is a light ray propagating from one medium to the another medium, as you see here, right? So here as per rectilinear propagation of light, what we can expect. So here it can propagate from one medium to the another medium in a straight direction. Suppose if I assume this red color spot, what I am showing you on the screen, as a interface that which can separate two different mediums, right? Two different medium. Suppose here this side you have something, it may be another surface, suppose water. What happens? So here it is actually in the medium called air, it is in the medium. Then now it is changing its medium into the water now. So this line we are calling that which can separate two mediums. It is very, very thin layer that is separating two different mediums called a interface. We can call it as interface. So at the interface, that light ray is changing its medium. So at this medium, automatically we can see bend that goes in different directions. Suppose if that light ray is observed to move or propagate in this direction. So here, simply it given you something bent at the interface. This phenomenon is called refraction. So bending of light ray at the interface is given as simply refraction. Then here, what is the cause of refraction of light here? Why that light ray giving this phenomenon or bending at the interface? So simply here there are simple reasons. One is according to the Faraday-Fermat's principle, what we learned in 8th class, light always chooses least time taking path. Why it changes its direction to take least time taking path? Why is choosing least time taking path? When there is change in the speed of light. Actually, what is the speed of light in the vacuum? That is 3 into 10 to the power 8 meter per second. But here condition is given, especially it is mentioned in the vacuum. Is there vacuum around you? No. We have medium, that may be air, water, glass, any other else. Solid, liquid, and gases. So in different mediums, that light will be allowed depending on the optical nature. It may be opaque, transparent, translucent. So here, especially we are dealing transparent mediums. Transparent. So suppose here it is air, transparent medium. Okay. Then water, clear water, pure water, transparent. So in them, light deviate from its path. That deviation only given as bending here. So bending or deviation from its path is called refraction. So why it is changing? Maybe there is change in the speed of light and one more change in the medium. So when the light changes its medium, right, here in the vacuum only it is propagating with this speed called 3 into 10 to the power 8 meter per second. Any other medium, the speed of light decreases. So the propagation of light with the less speed. So according to Fermat's principle, light deviates from its path to choose least time taking path, decrease in speed. So simple reason we can mention here, there is change in the medium and change in the speed of a light. So that is the reason to refraction of a light. So simple reason is given for the refraction of a light is change in the medium and change in the speed. Then next question I am asking you here, what are the applications of this refraction of light? Are there any applications? Yes, there are applications of these refraction of light in our day-to-day life. They are here mirages. In 9th class, we learned majorly 3 applications in our academy. What they are here? One is simply here. It is mirages in the deserts. In the deserts, or maybe on the road surface, you are able to see something. Water, appearance of water. But when you actually reach their point, at that point, disappears. Image of the opposite vehicles will be observed on the road surface. When you go there, no water. So we thought there is something water body. That's why the image of the opposite vehicle will be observed. But when you go there, really there is no water. So this is optical illusion called mirages. The next we have applications of that. Brilliance of diamond is given. Always the diamond shine bright, shiny. So it is total internal reflection called a refraction phenomenon. Then optical fibers applications. Optical fibers. in the medical hospitals. Then twinkling of stars, lenses, where we can use them here in the specs, in the doors, I spy hole, then in cameras. So these are the applications of the refraction of light. In human eye also we have importance. What is eye? Eye is a lens. In your 9th class biology, sense organs topics you learned. In the topic, especially about human eye and parts of human eye lens. So that can also refract the light to form the image on the retina. So these are the applications of refraction of light in your day-to-day life. Then here, next one is simply about why does some people use specs for reading a paper, or maybe while they are reading something in their books. Some people may use as specs. Why do they use specs for reading the newspaper or the textbook or something information in the paper? So why do they use? Actually, they have visibility problem. To make it correct, or to visible the text on the paper or book, they are using specs. To visible the text clearly, simple, we are able to answer. Right? The next question here to answer is, why do watch repairer use magnifying glass to see tiny particles of a watch or cell phones, or in the electronics, TV or something gadgets that can be repaired? So here actually watch parts are very smaller. While they are repairing, what do they use? Simply they can use something glass, eyepiece, so they can wear to see it. Or they may use magnifying glass. Why do they? To magnify, to see the size of that simply parts enlarged in size, in the large size. So that's why they are using magnifying glasses or eyepieces they are using here. Then here, simply, what do you notice when you touch a magnifying glass? If you touch, right? So move your hand on the surface of the lens, holding your fingers from the bottom one finger and the top one finger, move it on the surface, on two surfaces of lens at a time. So what do you notice here? Simply we can notice that the surface has a different thickness on its surface, different thickness on its surface. So here simply that surface has flat surface or another. So it is not a plane surface. It has simply curved surface. It is not a flat surface. It is not a plane surface. It is curved surface. It is a curved surface. So here simply, what is a curved surface? So we decided it is not a plane surface. What it is? A curved surface. Do you know what is curved surface? Simply the curved surface is bulging out or curved inward maybe. Suppose if you hold your palm like this, hand like this, eyes in the shape of snake. So here you can see your palm inside. This upper portion bulges out. So this is called curved in shape. As you see your spoon surface, or your geometrical box. What is simply the geometrical box shape is not geometrical box. It is your protractor. So here look at one surface straight and another surface is not same, opposite, bent. So this is called a curved surface. This is called a plane surface. So you have two surfaces, right? So like that you have to differentiate that surfaces here. Then the next question is about simply, is it thick in the middle or at the edges. What? Your lens, magnifying lens. So when you move your fingers, what do you feel? You are feeling that the thickness of the glass lens is thick in the middle, and at the edges it is thin. So thick in the middle and thin at the edges. It has different surfaces. It has different surfaces. One is thick in the middle and the other is thin at the edges. Then here simply introduction part completed. Next we are moving to the activity 1, that is which is given in the first page of your textbook lecture. So here simply just you can follow that activity. Simply it is asking about simple task, observing an arrow through the empty transparent glass, cylindrical glass, and that cylindrical glass filled by water, again observing the same arrow. So here simply observing the arrow through the empty glass and through the glass of water. So you need a transparent glass. So here simply I am giving you when the glass was empty. When the glass is empty. So take a paper. On the paper, you can draw a line. You can draw a line. So here actually you are using that arrow horizontally on the paper. So use landscape mode paper. Also you can draw line horizontally, but here for my convenience I am using that arrow vertically. Actually I am unable to show you that arrow in this direction. If I show you that arrow in this direction, what happens? Here simply you are unable to observe that clearly. If I show you like this, what happens? So that's why I'm showing you vertically. But you have to draw, as I drawn here, blue colored arrow horizontally, right? So here simply I'm using my arrow vertically, but you have to draw horizontally. Okay. Then take one empty glass, cylindrical shaped glass, empty. Then what to do? You need to observe that arrow from another side of the glass. So here, suppose left side you have the paper with arrow. Then in the middle, you put the glass on the table. Then move another side to view the arrow through the glass. So as you see on the screen, just position yourself to see the arrow. So it is very clear how to observe that arrow. So arrow is arrow, that glass and the person all are in the same straight line. Glass is in the middle and the paper, person are either sides to the empty glass. So this is the position. Then you are going to observe that empty glass and paper. So just try to see the arrow, then realize what you are observing. What you are observing. So when do you see actually? When you are able to receive the light from the arrow on the paper. So you are receiving that light from the arrow through the empty glass. So here I am considering top ray and the ray from the bottom of the glass. So bottom of the arrow through the glass. So here when that arrow light rays reach to the surface of the glass, what happens? So here you can observe clearly what is there here. Air is a medium. Air is a medium. And then you have a medium called glass. You have a medium called glass. Then inside the glass surface, what you have? Air is a medium. Then again, here you have a edge of the glass, another side. So two times you have glass surface, then the light ray is coming out. That medium is again air. So we have the mediums differently. So what happens when there is change in the medium? While the light ray is propagating, if it changes medium, according to Fermat's principle, always it chooses least time taking path. So here, when there is change in the medium, change in the speed. So change in the medium, change in the speed. That phenomenon give you refraction. So automatically it bends, then reaches to your eye. So when it reaches to your eye, what happens? It comes like this. So bending. When you see clearly, top ray bending downwards, bottom ray bending upward. Sir, same surfaces, but that bending is in different directions. How it happens? So here, if it happens, okay, imagined, if it happens, what happens to the image? Actually, you are receiving the light from the object called arrow here. What is your object? Your object is arrow. Then you are viewing object or the image. You are receiving the light ray through the, always whatever it may be, you are viewing, that is image, not the object. You are viewing the image of the object. So how it will be, we'll discuss in the 5th lesson, human eye. But here simply, whatever it may be, you are viewing without using anything also, because you have a lens in your eye that can form you real and inverted image on the screen called retina. Right? So you are viewing the image of the object. So you are receiving the light. Then the image is observed by you here. So it is visible to you. Same as the size or change in the size that you can realize. So that observation point is about the image. Size is same or changed. So here top ray and bottom ray you are receiving. Top at top only, bottom at bottom only, but that they are be converging, appearing to. So here simply the image will be formed in between them. So compare the sizes. Are the same? No. Here the size is observed. Size is observed smaller than the original. So diminished image you are viewing, and facing direction same as like your object called erect. So for smaller, we can use one particular word called diminished. So diminished image viewed by you. Diminished image viewed by you. Erect image and diminished image is observed in the first case. In the first case. So I think it is clear to you. Then next, that same arrow using the same glass, observing again, but the condition changed. Water filled into the transparent glass vessel. Then in this case, what happens that we are going to observe. So in this case, we have decided erect and diminished image viewed by us. Then now the glass is going to be filled with the water. So when the glass is filled by the water, what happens? Now you are taking the same glass with the water, using the same arrow facing upward, same size, then observing that from another side of the glass, same position. The next, what happens? The light reaches to the surface from the top of the object and from the bottom of the object. But you need to notice one thing. In the previous case, we have air as a medium outside of the glass. Then here you have glass and water together. They are in contact directly. So here we can take it or consider this whole glass and water as single medium, right? Considered as relative refractive index together. So only act as one medium. Maybe it is ice water or maybe ice glass only, but depending on their refractive indices, relative refractive index, so we can consider as only one medium, right? Neglecting one. Okay, then what happens? It comes out. But here what happens when you observe that through the glass of water? So here this is going to be happen. Simply that light received oppositely, top gone to the bottom received at the top. So one is bottom and the other is at the top. One is received at the top and the other is received at the bottom. So what happens? So your image of the object will be viewed like this from another side. And the size you can compare here. It is large. We can call it as enlarged image. And the facing direction, object is upward and the image is downward. So we can call this image as inverted image. So why you are receiving this image as inverted and enlarged? But in the previous case, when the glass was empty, you noticed that erect and diminished image. So what may be the cause or reason? The secret behind this change is simple. The glass was empty and the glass was filled by water. So because of presence of water in the transparent glass, maybe it happened, right? So clearly we are trying to understand what the phenomenon behind these changes, right? So that purpose here simply I am showing you clearly what is happened with the activity in the same observing the arrow through the empty glass. So here just I am taking two arrows facing same direction, having the same length, having the same thickness, no change in the thickness and no change in the direction. Two arrows taken. Then I am observing through the empty glass. So what happened? What happened? They are at same side and compare their sizes here. Are they in the same size? No. Here I am observing that is smaller but faced same side. Smaller, faced same side. So I call that erect and diminished image. But when that same arrows are observed through the glass filled, so look at that. Clearly I am showing you when the glass brought with water, one of the arrow direction changing and its thickness increased and size also increased. So facing direction changed to opposite side, facing direction changed to opposite side and its size improved. Compare that sizes, right? So that's why I am given you one is inverted and the other is enlarged, magnified image. So here, simply when the glass was empty, diminished and direct image is formed. When the glass is filled with water, that arrow through the glass of water are observed as here, enlarged and inverted image. So here simply you are generalizing that what you noticed here. See actually what happened when the glass was empty, that size smaller, right? But glass is filled with water, change. So here once erect and diminished and in other case glass filled with water, inverted and enlarged, magnified image is observed. So that is given in the next page of your textbook, in that page. So these are the observations from the activity 1. But here in the same activity, they are asked you what happened in this phenomenon or in this process. Can you draw a ray diagram or can you explain that phenomenon using the ray diagram? So now you are able to draw the ray diagram for the phenomenon. What happened? The reason simply to see the diminished arrow through the empty glass. So now you are observing the process from the top of the glass. Up to now, side view. Up to now, side view. Now you are observing that at the top. What happened? So in the top view, so that glass is taken as like this. So top view of the glass will be observed like this. So from the side view, you can see that is differently. So here actually what you are able to view that glass is like this from the top. So only top view discussion. So nothing worry. So here top view, we can consider only concentric circles. You have a center. You have a center for this, right? Then discussion is about the medium. What you have outside the glass? Air is the medium. Then here, what this circles, concentric circles representing thickness of the glass. So the medium is glass. The medium is glass. What about inside the glass? Right? The inner space of these concentric circles, nothing but air. Outside of these concentric circles, air. Then look at the center of the glass, given as red spot. Concentric circles, same center. Concentric circles, same center. Right? So here I have the mediums. Now I'm taking the same arrow to explain about the process. Right? So here arrow is taken, then viewing. So in this process, what happened that I am observing from the top view. So top view, that light ray received onto the surface of the glass. So what the surface is? Curved surface. What the surface is? Curved surface. Then we know what happens when the light ray reaches to the interface. What happens to that light ray when it is reached to the curved surface? It bends. It bends. So bending. That bending also observed towards the normal or away from the normal. In the pencil activity, that pencil when you place in the glass of water, that will be viewed by you, eyes, bending inside. Suppose here I am showing you in a glass of water, right? If you place a pencil, what happens? So at the surface will be observed that is going to bend, will be observed that is going to be bent like this. So here simply you can imagine a normal, that is normal means simply a perpendicular to the surface. Normal means perpendicular to the surface at the point of incidence. So these red color lines are what? They are here called as normals. So with the normal, you are now observing actually what happened. Bending. That light ray actually reached up to here straight, but at the interface bend. So in which direction that is bent? Based on the angles, you are noticing that it is bending. See here, angle decreased. So we can generalize that bending towards the normal when the light ray propagating from rarer medium to the denser medium. So rarer medium is what? Air. Denser medium is what? Water here. So what? Air to water, that I am giving you as rarer to the denser. So here in the rarer medium, what happened? It is bending. Sorry, in the denser medium, what is happening here? Rarer to the denser, that light ray is bending towards the normal. How I am decided? That is based on the angles. So here angle of incidence is smaller than angle of refraction, that I can call it as away. If that angle of incidence is greater than angle of refraction, I can call it as towards. So here that light ray bends. Towards the normal from rarer to denser. If it is from denser to the rarer, away from the normal. So this is generalization. So based on that generalization, I am here simply and considering the normal. So which is normal? The normal is simple for the curved surfaces. The line joining the center and the curvature is called a normal. As we learned in the activity 1 of reflection of light chapter. In the first chapter, reflection. So that we decided normal. So viewing the arrow from this side, then receiving the light ray. But in that process, you are receiving the light through the empty glass. Through the empty glass. So here that light ray is changing the medium. So for that I am considering the normal. I am considering the normal. So here simply at this spot, especially at this spot, the light is changing its medium from rarer to the denser, only in the thickness edge of the glass. In that place, it is changing its direction. So rarer to the denser bends towards the normal. So that's why here I am showing you the light ray very close to the normal. Then again, while reaching this spot here, to this spot, again, from the glass to the air, the light propagating. So in that, what happens? Again, change in the medium observed. That is glass to the air, denser to the rarer medium, bends away from the normal. So again, normal considering. So in that, you need to observe that bending of light ray goes away from the normal. So here, simply at that lines, I am trying to show you with the curvature. So when the light reaches here, I consider the normal. So in this comes closer. Then again here the light ray is changing after reaching this spot. So again one more normal is considered to this place. It moves away from the normal. So this exactly I am trying to show you in the diagram. So look at that clearly. Then after reaching the another edge of the glass. So this is inner view, inner surface. Then reaching another boundary at this place. Again, it is changing medium. Again, that is changing the medium. So rarer to the denser bends towards the normal. So consider the normal to this surface. At this place, again, the light ray bends. Refraction takes place. So bends towards the normal. So light ray goes very close to the normal. Then another edge. So another circle reached. Outer circle. Inner circle. So that inner space between these circles is called a glass medium. So another circle reached. So at the other edge, again, the changing medium from glass to the air, called denser to the rarer, bends away from the normal. So that goes away, right? Then again in this bottom. So bottom also same discussion. So here reached into the glass medium, so bends toward the normal. Then glass to the air, bends away from the normal. Then goes to the another edge of the glass, inner surface viewed. Okay. Then air to the glass, bends towards the normal. So okay. Then another edge. Then glass to the air goes like this. So they are becoming close to each other. So that inner gap is size of the arrow, image viewed by you. So this is happened in the empty glass of water. So in this, what you are generalizing, simply that size is diminished. And facing direction is same. So erect image is observed. This is happening, the phenomenon in the empty glass. So that we observed in this page. Then next here, what happens? That is filled with water. Magnified and inverted image is observed through a glass of water. Sorry, here empty glass is written, through glass of water. Right? So in this, simply what you are trying to notice, that is inverted and magnified through glass of water. Then here, simply outside of the glass, we have the medium called air, rarer medium. This circles and this shaded region, glass and water, relative refractive index is considered. So considered to be one medium, only one medium is water, because they are very near refractive index of water and refractive index of glass. 1.33, 1.5 approximately considered to be same. So that will give you relative refractive index maybe 1.44 like that. So one refractive index is considered. So that's why I'm showing you one medium. So then the center is considered. Only one refraction at left edge and right edge considered. In the previous case, light bends 4 times, but here only 2 times. So look at that. So when you observe that arrow through the glass of water, we noticed simply here that inverted image and magnified image. The phenomenon behind that we are discussing now. So only one refraction is considered only at the outer surface, because no inner surface, that is not considered. Here only the outer surface is considered, right? So bends, because here rarer to the denser medium, So that's why here simply that light ray bends towards the normal. It goes to the another edge of the glass directly. Then at another edge, again, it is changing the medium from water to air. So it goes further refraction. So here consider the normal. Denser to the rarer, bends away from the normal. So it goes like this, downward. Then next, from the bottom of the object, received that light onto the glass surface. Then again, see here, changing its medium. Consider the normal. So rarer to denser towards the normal, rarer to denser towards the normal. Then what happens? That light bends. So move onto the other surface. Then again, changing its medium denser to the rarer. Then moves away from the normal. So moves upward only. Just here, concentrate on the angles. They are increased or not? Or they are decreased or not? That you have to notice. So simply based on that concept, I drawn ray diagrams for this situation. So here, top ray received at bottom ray received at the top. So here, the top of the object is give you at the bottom here. Here, bottom of the object is given. I stop here. So that's why you are viewing that image as inverted here. Okay, I got it. Clear? So now ray diagrams of this completed. So here compare the sizes. You are viewed that arrow is magnified and oppositely faced it is. So we can generalize that inverted and enlarged image is viewed through the glass of water. So this is observed. Then here, simple thing asked, that is here top to bottom ray reached at the bottom and top oppositely. So now here come to the questions asked in your textbook. Why do some people use spectacles for reading paper? Already we answered. That is for visible the text clearly. Then why do watch repairer uses here? It is to see the tiny particles, right? So here already we answered. So with that, now we are deciding all these. What may be the watch repairer used, or what may be the person using the spectacles, that lenses or magnifying glasses, all they are having the curved surfaces. So what is actually curved surface? So two-dimensionally, what we can call it is that something deviating from its path, always changing its direction, an arc, or maybe the circle, or maybe the sphere. They are treated as here curved shapes, as you learned in the mathematics, right? Shapes, different shapes. So planes and curved. 2D, 3D we observed, right? So in that, so we learned about curved surfaces as something change in its direction, bending always. So mathematically it may be circle. Mathematically it may be circle or maybe the arc. So they are called as here curved surfaces. They are called as here curved surfaces. So here, this if you are observing from the left surface, from the left surfaces, suppose I am giving you that arrow from this surface. If you are observing that curve, so how do you feel? So it is something bulged outward, right? So that bulging out surface existing, so exit out, right? So that meaning is given. So that's why convex, simple logically I am giving you. In this you have x, convex, existing, bulged out. Existing meaning is what? Out. So bulged out. So that's why I am giving you code. So convex surface, bulged out surface. So easy to identify that surface. Existing means out, coming out, right? So something out, output. So out surface, bulged out surface is called a convex surface. Then if you see another surface that is bent inward, curved inward, that we can call it as concave surface. Cave meaning is inward. Cave meaning is inward. So here simply concave surface, right? So maybe you are having different surfaces. This you can consider as interface here, that you are considering as interface. So this line, blue colored line, curved line is given. So this is now your interface. This is what? Interface. So this interface is now curved surface. Maybe one side you have denser medium, another side you have rarer medium. Suppose here I am giving you one of the surface as denser, having water. That same simple glass. Inside what you filled? Water. Its outer surface is what? Curved surface. Circular. So that we can call it as denser medium. Outside is air, rarer medium. So this is, you need to keep in your mind. Now we are going to deal with the curved surfaces, because the phenomenon observed in the activity 1, bending of that light ray, giving you different images when the glass is filled with water and the glass was empty. Enlarged, diminished, erect, inverted. So oppositely you observed. So why it is happened? That we are trying to learn by learning the curved surfaces and its terminology. So this is curved surface and the terminology we are using. Curved surface, bulged out, convex surface. Curved inward. Inward meaning is cave, concave surface. So convex surface, concave surface. We have two surfaces in curved surface. What they are? One is namely out, existing, convex surface. And the other surface, inward. Inward meaning is concave. Cave meaning used. Concave. So curved surfaces are two types, convex surface and concave surface. Then they are maybe separated by two different mediums. So one is air and the other is water. So air is considered to be rarer medium and the water is considered to be denser medium. So that we are noticing every time. So what the surfaces we have around that curved surface, maybe the rarer or maybe the denser. So now we are trying to focus that simply on the terminologies, So here simply what the terminology is here now. That terminology is here simple. Simply on the curvature, you are identified one midpoint. So before going that, I am completing that what a curved surface and the mediums what we have. Convex surface side, bulked out surface side is rarer medium inside shading, I'm giving you something different color. Shaded portion is given as you water, denser medium. Then that curved surface on the curvature, we have a midpoint. That midpoint is called here pole. That midpoint is called here pole. On the curvature, identify, locate a midpoint. That midpoint on the curvature is called pole, represented by P. Then imagine this curvature is a complete figure. What you will get? A circle shape. So it has what? Center. So that center I am giving you as center of curvature for the arc. So simply you are having that surfaces curved surface, and you have pole and center of curvature. What is pole? The midpoint on the curvature. The midpoint on the curvature is given as pole. Then that curvature is imagined as complete figure, closed figure. So here you will get outline is circular shape. So that shape has center. So that center only act as center for the curvature, right? So it is imagined as three-dimensional. Center of curvature is formed from the sphere. So that sphere center only act as for the center of this curvature. Okay, so center of curvature. Then I am joining these two with a line. The line passing through the pole and the center of curvature is now given as principal axis. Principal axis. So I have principal axis, pole, center of curvature, rarer medium, denser medium, concave surface, convex surface. So these are the terms I learned in this topic. Then now the question is, what happens when parallel beam of light rays focused on the curved surface? When the parallel beam of light rays focused on the curved surface. So here I have knowledge about that refraction, bending of light ray from rarer to the denser medium bends towards the normal, denser to the rarer medium bends away from the normal. So now I am using that knowledge here. So according to that, simple, I can say the light ray bends towards the normal depending on the medium. From which medium to which medium? Suppose here in this figure, I am showing you the light ray is propagating from rarer medium called air to the denser medium called water here. So water is denser medium and the rarer medium is air. So the light ray is propagating or directed from rarer to denser. So in this case, what happens? Light ray bends towards the normal. Light ray bends towards the normal. So bending towards. It is bending towards the normal. So that I can use here. Simple logic. Rarer to denser towards the normal. Okay. Rarer to denser towards the normal. Simple code you can put for remembering. Suppose here rarer to I said RT. Denser towards the normal. So I am using the code. Here RT dt. Rarer to denser, then towards RT dt. Why I am using rarer to denser towards? So bending is towards, that you can imagine. So here I need normal. So what is normal? Simply normal is, for a curved surface, normal is the line joining the center of curvature and the boundary. So why it is considered to be normal? Because that line drawn from the center to the boundary is perpendicular to the tangent only at the given point. So that's why it's said to be normal. So incident light rays are parallel. Now consider the normal. Why it is called as normal? if you imagine what? A tangent, that line which can meet the boundary only at one point at the given point. Right? So here simply it is perpendicular. It is perpendicular at this spot. So that angles are considered to be here perpendicular. So that's why here the dotted line is considered to be normal. For another light ray, it is not normal. To that you cut one more normal here. Draw one more normal. Right? So at all the points you are able to draw number of lines, because at that point only they are considered to be perpendicular lines. So you can consider. So this is, so I got normals for each and every line you considered here. Each and every line you consider here. So what happens? What happens? That light bends, already given you, rarer to denser towards the normal, RTDD. Rarer to denser towards. So here you are observed that light ray bending rarer to denser towards the normal. So here it is in the medium called air and it goes into the medium called water. So rarer to the denser bends towards the normal. Simple. Angle of refraction decreases. Angle of refraction is smaller than the angle of incidence. So in the figure 2 it is given. So that normals you learned in this topic actually. Bending we are not showing. Bending we are not showing. So based on one observation, I will give you in which direction it is bending. So observe this figure. Observe this figure closely. So here pencil, same pencil is placed. Right? When you place the pencil, you are observing as two portions, upper and lower to the water. Upper portion above the water and below the water. So what happened? Two parts observed. No connection. No connection. So simply what you are noticing here, I am considering the normals. Look at this. So I will move that to the right spot. So wait here. Now I move this. So simple. What happens? See. What happens? See here. Right. So I is a single line. I show you now. Simple. At this spot, what you are going to notice here, look at. So this is interface. Above the water, what happened? The light bent. The light bent. So here simply above the water, what you placed? Pencil is placed. So pencil I placed. So now inside the water, what I noticed differently. So why like that? I'll show you in the diagram now. So look at, I'm taking a normal with the green colored line. I'm taking a normal with the green colored line at the right spot now. So where that light changing its direction. So imagine this line as a light ray here. So light ray reached to this point at the interface. So this line is interface. So at the interface, light ray is changing its direction. What happens? Here, this is air medium. Inside, you have water. So in the water, what happened? Pencil observed as bending. So why it is? Because change in the direction of light ray. Change in the direction of light ray. Inside the water, that light ray is going to bend like this. At this place also, that light ray bends like this. So here look at the upper portion and bottom one. Upper and bottom. What happened? Is there any connection? They bent. So depending on that, you are viewing. So here you are observing exactly with the water level. If you are observing this, you can see, right? From the top surface of water, you can see like this. Right? So realize. So based on that, I'm giving you code RTDT, bending towards the normal. So coming closer to the normal, look at this. Here it is somewhat away. Angles are different. Angle of instance, this one, this gap. Angle of refraction, this gap. These are, you need to observe clearly. So this is actually happening in the refraction of a light. So for that, directly I am able to show you that angles here considering the interfaces bending toward the normal. Look at them. Clearly look at them. Bending toward the normal, bending away from the normal, bending towards the normal. Here see angles decreased in this region comparing with this region. Here also you can notice, if it is imagined to this surface, here the angle is this portion. Inside, what happened? Became smaller. So that's why RTDT we are using. Rarer to denser towards the normal. RTD, rarer to denser. Another T towards. So use this code to avoid your confusion. Simple logically we can follow, right? So in this case, simply the parallel beam of light rays is focused on the curved surface. What happened? It changes its medium. Rarer to denser. In this case, simply when the parallel beam of light rays focused on the curved surface, right? On the curved surface, we will discuss with the different light rays. So that will be discussed in our next live class. So just follow my live classes and also give me your valuable information regarding these classes as comment, right? So comment about these classes, how you are feeling. Also you can share these classes if you like with your friends, otherwise skip it. Give me your comment, like or dislike, like and also comment, and don't forget to share it with your friends. Thank you. I'll join you on Sunday again.